Hello grade 12s, welcome to my channel, and I hope you guys wrote well and did your very best even in the suplex city right here. So we're going to try and survive the Brock Lesnar. So thanks to my student Retabile, we've already had a look at this one, so I thought I should share some of the pearls that you could have applied here and also maybe highlight why this was truly a suplex city compared to the usual. So we're going to do this question 10. Okay, nice and easy. Sidlela makray nice. Nobage khona indawana ezikhalisayo. Okay, masiyeni ke bafowethu. In the diagram PQRS. So where is that? P, Q, R, and S. So I cannot annotate this one better, so just have to follow those dots. It's a cyclic quadrilateral. Obviously, the points are at circumference such that PQ is equal to PR. So now we are told here that PQ is equal to PR. Okay, maybe let's use a different color so that we can spot this nicely. So PQ and PR are equal. If those two are equal, this is suggesting that that angle should be equal to this angle. Now those are angles opposite equal sides in triangle PRQ. Okay, now we're told here the tangents to the circle through P and R. Can you see that should be the tangent? That should be the tangent because of those points of intersection being stated. Meet QS produced at A. So there's QS is produced at A. So we've got this tangent number 1. Maybe let's put another color. So there's the tangent 1, there's the tangent 2. And they essentially meet at this common point A. Okay, not a problem. Now what do we do next? So the next piece of info is that RS is produced to meet tangent AP. RS is produced to meet tangent AP at point B. So this is where there is this intersection. Put that arrow there. Then we're told also PS produced meets tangent AR, which is that tangent over there, at C. So that is the place where things are happening. So there is the meeting spot. All right, so we're told here PR and QS intersect at M. Okay, so there we can see the point of intersection. Maybe let's make it a bit more visible. I don't know what color could I use there. Maybe the pink color. Maybe let's remove those and put the pink color. All right, so now what do we do, guys, with all of this information? Well, there's quite a lot that we can actually equate. If we're looking at angle Q will also be equal to angle R. But now that color is not quite as deep as I would like. So maybe let's make it small right there and say, fine. We know, but maybe you guys are not going to see, but we know that angle R1 plus R2 should also be equal to angle Q. Why? That's the 10 chord theorem. Okay, great. Not a big problem. All right, so now what is next? We can also see a whole lot of other things. Hey, but this diagram is busy, man. It just makes life a lot difficult to try and pinpoint certain things. But we can also see that essentially there's quite a lot of equalities, just too many, guys. But let's try and highlight a few. We can see that this Q1, maybe I'm not annotating it in the best way. This Q1 is going to be this angle R2. Those are angles in the same segment subtended by chord SP or arc PS. All right, And then same story, we've got a 10 chord theorem here that this angle P1 should also be equal to this angle. In fact, maybe we should have kept to this. Maybe we should have kept to this one. Now we know that, well, angle R2 is essentially equal to angle P1. That's the 10 chord theorem. And again, P1 is effectively equal to Q2 10 chord theorem as well. All right, not a problem. What else can we note? We can note that this Q1 plus 2 should be equal to that angle. That's an exterior angle of cyclic quad PQRS. But that is also vertically opposite that angle. So that is essentially the story there. So now there's just too many things. The diagram gets botched and it becomes a bit of a mess. So it's easy to botch everything here. So with the fear of not making this too messy, we'll just have to look into the diagram for other connections. So what we have to do now, we just have to keep going. So what do we do here? Question says, prove giving reasons that S3 is equal to S4. Okay, S3 is equal to S4. We can put a question mark on S4. How is that possible? Okay, looking at S4, basically S4 is equal to R3, right? Angles in the same segment subtended by arc QP or PQ. And then that angle is equal to angle Q1 plus 2. We were told that RP is equal to RQ. So those are the angles opposite equal sides in that triangle RQP. But we know that Q1 is equal to S3 because that's an exterior angle of a cyclic quad. So therefore, these two connect through Q1 and Q2. So we can safely say, therefore, S3 is equal to S4 in that regard. Okay? Now we just have to make sure we make these connections just right. Since we're starting with S3, let's start with S3. So 10.1. We know that angle S3 is equal to angle Q, angle Q1 plus Q2. Okay, maybe you can just put them in brackets to show that that is a unit. So what is the story there? This is an exterior angle of a cyclic quad. Wait, let's name it because we're just going randomly now. PQRS. So when you are random, try to direct the person who's marking you. Where are you working at? And what are you talking about? Because sometimes just say exterior angle of a cyclic quad. Yes, that is the only one that was mentioned. But what if we are talking about the next one, SMRC, which is the next question? So be careful of creating ambiguity. Okay, so first of all, I'm forgetting that this is not a calculation. I'm about to write this implies. Now, what do we have? We're going to say here also, okay, what are we going to say? We know essentially that angle S4 is equal to, angle Q1 plus Q2 as a unit is equal to angle R3. Okay, what is the reason there? We can say these are angles opposite equal sides in triangle. Now let's take the triangle. This is going to be PQR. Okay, given PQ is equal to PR. So guys, your reasons can be elaborate if you have to. So you don't always have to make them too little and you are just vague. You're just like writing a telegram. But it's okay. There's no harm. Sometimes you're forgiven for this because this is all overwhelming. But proper practice and regular, attention being paid to some nuances in these problems, it makes life a whole lot more easier, even for the person who's marking, to just gel with you and to be able to even forget they're marking you. They start praising you by giving you marks you don't even have done. They just give them to you. Anyway, let's go on. So what are we getting at? We've got a story to say, but angle R3. But angle R3 is also equal to angle S4. Okay, what is the reason there? These are the angles in the same segment subtended by, now we can call this one chord PQ because we've got a chord in there. Or you can use arc, it's still acceptable because chord or arc is one and the same thing in terms of reference, but they don't measure the same distance. The arc is always longer than the chord, okay, because of some distance issues. Okay, think of this as a distance and that as a vector. Okay, you understand physics most, isn't it? So that should not be an issue. So now what can we conclude? Can you see, guys, that our issue is that the link now through all of this is this center right here. So this center right here, this is the link to all what we want. Oops. Bamba ngenye suplex or power slam nyana, o tla bona dintho. Le nna ke di bone he, e seng wena kaofela. I mean o le mong o kampa lona kaofela. Le nna ke bone ntho mona. Ke ile ka bona tosa le madinyane wa yona. Handlentle. Ha re yeng he. Now, what is the story that we want to do? We essentially want to conclude therefore that S3 is equal to S4. Okay? Why is that? We can see, guys, that the link is that each is equal to R3 equal to Q1 plus Q2. So I am always the guy who accepts a bit of creativity. Because when things are not directly linked to just one thing, I always try to show that here is the common link between these two, so that somebody can understand that, okay, this is why situations are like that, because those links are what are important. So this is done. So that is the first 5 marks in the bag. How do you get these? This is obviously a very strong mark. This is obviously a very strong mark. This is a very strong mark also. And this is a strong mark. Maybe we can give you 2 marks because we've had to give a statement maybe and a reason that is a bit interesting. So let's just leave it at that because I cannot find a way of answering this one better. Ne? So that is it. So here we can say just that statement and the reason. Perhaps the last 2 marks come in there. Okay, let's move on. So 10.2. Okay, that was just breaking the ice essentially. So let's go. SMRC is a cyclic quad. So where is that SMRC? Now let's try and find a way of annotating it. So this is S. We'll just make these dots go around here. SMRC. Okay, so there's our cyclic quad. I'm sure you guys can appreciate it as much as I'm working with a bit of challenges here. All right, so now how do we prove that? Okay, so the way to prove this one is a cyclic quad. We have just proven at this point that this angle right here is indeed, we have just proven that now S4 is equal to S3. Okay, please indicate those using pencils. Rather use colored pencils that you can rub off when you need to, because those permanent markers may cause a bit of a situation for your diagram. Okay, now we have just proven that. So what do we know? What do we know? So for us to say this is a cyclic quad, can you see R1 plus 2 is now effectively equal to S4? That is an exterior angle of a cyclic quad, and definitely that's a cyclic quad. So it's already proven now by just a small analysis and the answer to the first question. But now we just have to link these ones nicely, because we can't just say now that is the case. We need to justify why R1 plus R2 is equal to S4. Okay, so the best way to go about this one, we will say that R1 plus R2 is equal to angle Q1 plus angle Q2. Okay, what is the reason? This is the tan chord theorem. So now that's the bread and butter of Euclidean geometry. You will hardly have a question that misses this property. Now, after we've said that, what is the next step? We've essentially proven that Q1 plus Q2 is equal to S3, which is an exterior angle of yet that other issue. So essentially, now I'm trying to see, because I mean this question is a bit silly now. You see, sometimes some questions are silly because the connections are a little bit technical, you know, they are a little bit technical. But what I'm gonna do, I'll just make it my way. Okay, so I'll say, but I know that angle essentially Q1 plus Q2, okay, that is a unit and that is a unit, okay, is equal to angle S3. Okay, just always try to make the connections. And why is that? We can say proved above, or you can say exterior angle of a cyclic quad, as if you haven't said it before, if you used a different approach for the above. Okay, so now what are we getting to? We know without a shadow of a doubt that also S3 is equal to angle S4. Maybe let's write properly, guys. Ooh. Also, we know that angle S3 is equal to angle S4. Again, we've proved it above. Okay, now what is left is to make the connections. We can say, therefore, angle, what we're interested in is angle R1 plus R2 as a unit is equal to angle S4. Oops, too much excitement will kill you, so be careful. So now what is the link, guys? It's S3 via Q1 via Q2. So this question was a bit strange. The connections are a bit silly, but either way, we've got it in the bag. Okay, so what do we know now? We know that each is equal to effectively Q1 plus Q2 equal to S3, because that was the link to all of this business. Okay, we can put them there. So a reason really in Euclidean geometry does not necessarily have to be a theorem, okay? But they were the reason, okay? This is just the steps in maths. Now the steps in Euclidean geometry is essentially what you would say the reasons, because this is what links everything together. But in algebra, it's just all the operations, the order of operations, BODMAS or BOMDAS, or some call it PEMDAS overseas. Anyway, so we can see that, since we proved that angle R1 plus 2 is equal to angle S4, can you see that's an exterior angle of a cyclic quad essentially. So now we can conclude that therefore this SMRC is a cyclic quad. Now what is the reason there? We can say this is the converse. Oh, what did I write? Of exterior. Lord, come on. This is the converse of exterior angle of a cyclic quad. Okay, sometimes they give you so little space. I don't know how you guys manage. It's ridiculous though. The DBE must stop this thing. They must just give you a booklet like we were given that has perhaps the diagrams freely floating, because you still need the diagrams, and perhaps allow you guys to have some staplers, or I don't know how, but or you can just get a booklet that has this, and then they give you a booklet that has those diagrams, so that whatever you annotate, you put in the diagram, but answer in the booklet wherever you want for as long as you want, because I don't think it's fair for them to give you so little space. It's like they're giving you hard questions and then immediately placing you under pressure, and I'm like, what is the sense in that? It's absolutely nonsensical. I wish I could tell somebody in there about it, but of course it would come out as if I'm arrogant. But let's think about it more objectively and essentially not try to bend to this madness. It's unfair. It's totally unfair, because how would you do this in a short space if you need to say more before you are convinced you are actually getting the right answer? It's really wrong, man. You can't constantly be doing summaries of such technical information. It's not on. It's not on. And somebody is gonna get it, eh? It's gonna get donored, or if you're not donoring it, is what is the word they use in Afrikaans to beat somebody? Yeah, you're gonna get moord, but I won't say that word. Okay, folks, we are essentially done with the proof. So that is essentially the answer right there. Okay, so cool, we were getting 4 marks. So obviously this one, we haven't said it before, so we can say it now. That is valid to give a mark. And then for these ones that are proved above, we can bunch them together and give you a second mark, because those are the connections. And essentially the third mark would be this one. Again, it's a very weak combination, but it is something that needs to be realized. That's the third mark, and then the fourth mark is the answer with its reason. If you don't have a reason, that answer is invalid. Okay, so guys, let's do this one. Okay, those questions are not so bad, but they were a little bit of perhaps a choke slam, you know, or could you call it a power slam, but it's something that you can survive, you know. Yeah, but now let's see. Question 6, as you can see, 10.3 is like having a lot of marks. That means somebody's child is getting killed here. Somebody's child is getting murdered. But here's what I advise anyone who does these exams, is to just do your part. See what connects to what and put it down, okay? Whether it's going to be connected or not, once you don't have an idea, just put down whatever you can put down and start moving. You never know. Sometimes an idea may come up, and as it comes up, you go and correct. But of course, you start on the rough work when you answer questions like this. RW becomes your friend, because if you just go straight and right, you will mess up your space and end up not having a place to answer. So start brainstorming these things and checking. It says now RP is a tangent. Prove that RP is a tangent to the circle passing through these points. And this is a tangent at point P. So what does this question literally say? it says prove that this angle A2 is equal to angle A1, because that would be the 10 chord theorem. So now we want to know, is that so? So those are question marks. Those are question marks that we have to fulfill. Okay, my diagram is a bit messed up, but we can try. So how do we prove that these two are equal? A2 and essentially P2. As you can see, I'm saying they're equal, but I'm putting question marks because now that is what I need to prove. Okay, so what do I know? Now you'll notice that here tangents from the same point outside the circle are telling us that P1 plus 2 is effectively R1 plus 2. Can you see that? Maybe let's start there. Say angle P1 plus angle P2. Now these are angles that are a unit, so you can put them in brackets because we want to show that that is the unit, should be equal to angle R1 plus angle R2. Now what is the reason there? The reason is that these are, okay, maybe let's not start there. It's dangerous. We have to state something first. We can say AR. I don't know why I wrote here. Goodness, why am I doing silly things now? We can say now AR first is equal to AP. Why are those two equal? Because these are the tangents from same point. Okay, great. Now, what do we see? We can say this implies that angle P1 plus angle P2 as a unit is equal to angle R1 plus angle R2. Those, don't forget the caps, as a unit. What is that? These are angles opposite equal sides in triangle ARP. Always state the triangle when you're just going freestyle and just throwing statements. Try to direct somebody, what are you talking about and where is it? And the reason for that to be the case is because you've just stated this piece of information, because this is also a very critical part to mention. Okay, so now that we are there, we are fine. But what do we notice, guys? We will notice though that, however, we know that essentially angle R1 plus angle R2, can you see that angle there, is equal to S4, is equal to angle S4. Okay, that's great. But now what is the reason? Can you see? That's the reason that we did here just above. So here, instead of saying the reason again, you can just say proved above. So when they ask you to prove something, it usually is useful. When you think of suplex sitting, once you see the next question is challenging, just know there is something from the previous questions that you're going to have to use, and something new that you still have to discover or to point out. Okay, so now what does this mean? What does this mean? This means essentially AP, maybe let's drag this one, or maybe let's leave this one. It doesn't matter. We can say, okay, now what can we say? We know that also, what, mister? We know that S4 is equal to what angles? It's going to be equal to angle P1 plus A2, or we can say A2 plus angle P1. Now what are those angles? This is an exterior angle of triangle SPA or APS. Can you see? That side produced makes that S4 the exterior angle for that triangle. So we can say this is the exterior angle of triangle. Now, since we're mentioning a triangle we didn't speak about, going to be triangle APS. Oh, you guys talk of the APS score, is it not so? Huh? Okay, all right, okay. So now what does this mean essentially? Now what this means is that we can replace this in there, ne? And then we replace again that with this in there. Is it not so? Yes. So what does this mean? This implies, now we're going to start and say, okay, all right, okay. This implies that P1 plus P2, as you can see, is equal to, instead of R1 plus R2, because you can see the link, again, they just made these links so distant from each other that you've got to do two things that slightly not related to the rest, and then you connect, because you can see R2 is dragged to S4 and S4 drags this one to link up. So you can say P1 plus P2 plus, oh yeah, let's just break the brackets now, is going to be equal to A2 plus P2. Can you see that? No, P1. What are you doing? Now what is the story here? The story is that we can say each is equal to R1 plus R2 equal to S4. Ne? Still a valid reason, because we're just trying to show them that there is the connection where it's sitting. Okay, so I forgot the cap. Please don't forget the caps. Ne? Please. This is the notation that you need to make sure it's out. Now what is left, guys? We can see here that we've got like times P1 is also equal to P1. So that means these ones will cancel, because when you move them around, they cancel. We have proven now that P2 is equal to A2. Okay, sometimes izinto zivele ziphaphe nje. That means angle P2 is equal to angle A2. And that's exactly what we wanted to prove, isn't it? So that is obvious. You don't have to justify that one. Then we can conclude that therefore PR or RP, as it is stated, is a tangent to circle through, we can even say APS. We can say circle APS, or let's just write it as it is stated, through PS and A at P. Why? This is now, we proved that the angles to be equal that would fit a description of a 10 chord. So this becomes the converse of the 10 chord theorem. So that is done. Yeah, this one was a suplex city, guys, not child's play. As you can see here, you just have to keep jumping from one structure to the other. But if you keep trace of what you have done, usually it works. This is why your diagram must not be too busy. Don't annotate it too much, but annotate it enough so that you don't have to struggle making easy connections. Let something be truly hidden before you can say, okay, now I don't know what to do. But please use your colored pencils that you can rub off at least, so that when you feel like, okay, you're losing the track of everything, you start all over again, depending on whether time is on your side. Okay, so this statement and reason is important. Right. And this one is equally important. You cannot ignore that statement. Essentially, what I see here is also important is this one, because that one that's proved above, you already got a mark above, so you're not getting it again. Ne? And then what is also important, essentially, this is 1, 2, 3. We can say 4 and 5 because that conclusion is important. And the last conclusion with its reason is how those 6 marks are taken. So this is how you take the 15 marks of this question, with a bit of a salt in the mouth because it's not so tasty, is it? Alright guys, so I figured let me just share the suplexity, which is what is more challenging, and then I'm sure the rest was manageable. But I will keep looking through this paper and see if there are questions I think they're of interest to share. Otherwise, I will see you next time. Please prepare for the next exam as best as you can, and good luck with the progress in your exams. See you when I see you.